For this video, we're going to be looking at some examples of solving a right triangle. And so the directions say solve the right triangle and round decimal answers to the nearest tenth. So again, what we just learned is that solving a right triangle means that we need to know all the side lengths and all the angle measures. So looking at this first triangle, I see that I'm given two side lengths, but I do not know measures of angle B or angle A, and I don't know the side length of AB. And so looking at this, I want to first just note what I'm given. So again, I'm given two side lengths. And something that we learned in the recall is that we can use the Pythagorean theorem to find the third side of a right triangle when we know two side lengths. And so I'm going to use the Pythagorean theorem first. And so that says that's a squared plus b squared equals c squared. I know that c needs to be my hypotenuse, so I need to see which one is my c. Well, my hypotenuse is opposite of my right angle, and so that's going to be my side AB. And so plugging in, it doesn't matter which, the 3 or the 2 is my A. I'm just going to make 3 my A. So I have 3 squared plus 2 squared is equal to AB squared. 3 squared, I get 9. 2 squared, I get 4. 9 plus 4, I get 13. And then I'm going to take the square root of both sides. And so here you just go ahead and use your calculator. So when you use your calculator and you take the square root of 13 and you round to the nearest tenth, you should get 3.6. And so it's going to be approximately that. So we have the one side length. We know this is going to be 3.6. And now we need to find these two missing angle measures. And so that's where our trig ratios come in play first. And so let's say I want to find the measure of angle A first. I'm going to go ahead and use these two side lengths, 2 and 3, for my trig ratio. And the reason why I'm going to use those two sides instead of the hypotenuse I just found is that we approximated our hypotenuse. We said approximately 3.6. And so to be completely accurate with my measure of angle A, I want to use these whole numbers. So my first step is I want to see what type of sides I am dealing with. If I'm dealing with my opposite, adjacent, or hypotenuse. So first I see that from A, 3 is my opposite, and 2 is my adjacent. And so thinking of SOHCAHTOA, that means I am using TOA, so I want to use tangent. So I have tangent of A is equal to opposite over adjacent, so 3 over 2. And then we've learned that when we're finding an angle measure, we can take the inverse tangent. So I have tangent inverse. And so I get that the measure of angle A is equal to the inverse tangent of 3/2. And then I just need to put that in my calculator. If you're using Desmos, I'm going to come over here. First, I'm going to hit this wrench and make sure I'm in degrees. Otherwise, I will get a wrong answer. And then I'm going to click on this keyboard, go to functions, and then do 3 over 2. And so I get, rounding to the nearest tenth, that measure of angle A is 56.3 degrees. So I have the measure of angle A. Now I can find the measure of angle B, and you could go ahead and use inverse trig ratios again to find it, but an easier way to do it is remembering this last bullet point here, and that is when finding the third angle, remember that the two acute angles in a right triangle are complementary, so they add up to 90 degrees. And so that means that the measure of angle A, which is 56.3, plus the measure of angle B is equal to 90 degrees. So when I subtract that from both sides, I get that the measure of angle B is equal to 90 minus 56.3, which is equal to 33.7 degrees. And so now we know all the sides and all the angles in this triangle. Okay, let's try another one. So here I have my triangle ABC. This time I'm given one angle and one side. And so to find my other two missing sides, I need to again be using my trig ratios. So let's say we want to find side BC first. My first step is that according to A, I need to figure out what type of side that is. Well, I see that according to my angle A, BC is my opposite. And then my side 13 I see is opposite of my right angle, so that means that this is my hypotenuse. So thinking through SOHCAHTOA, I need to see which trig ratio uses opposite over hypotenuse, and I see that that is my SO. And so that means I have sine of 25 is equal to my opposite, which is BC, over my hypotenuse, which is 13. And then to solve this, I just need to multiply 13 on both sides. And so I get that 13 times sine of 25 is equal to BC. And so coming back to Desmos, I can go ahead and do that. So I have 13 times functions sine of 25, and I get rounding to the nearest tenth that this is 5.5. Okay, now we're going to do that same thing, but we're going to do that with side AC now. And so my 13 is still going to be my hypotenuse, but now when I'm looking at side AC, since AC is right next to my angle 25, this is going to be my adjacent side. And so now thinking through SOHCAHTOA, I need to think which one has adjacent and hypotenuse, and that is my cos, so I have cosine. So now I have cosine of 25 is equal to my adjacent, which is my side AC, over my hypotenuse, which is 13. And so again, multiplying 13 on both sides, I have 13 times cosine of 25 is equal to AC. So heading back over to Desmos, I have 13 times cosine of 25, and I get that that side is approximately 11.8. So I have my two missing sides. My last step is to find my missing angle. And you could use inverse trig ratios to do this. I don't recommend that. I recommend going ahead and using the fact that these angles are complementary. And so you have that the measure of angle A plus measure of angle B is equal to 90. Well, measure of angle A is 25, so I have 25 plus the measure of angle B is equal to 90. Subtract 25 from both sides, and you get that the measure of angle B is equal to 65 degrees.